Hello all. So today we'll see the Punnett square and its application. Okay. So Punnett square is nothing but a square, which is a straightforward method for prediction of the outcome of a cross. Cross is nothing but your mating here. Okay. If you are doing a male-female mating, how to find the gamete is the purpose. So now quickly see here. So three things we'll see: monohybrid cross, test cross and dihybrid cross by using the Punnett square. So now you come here, monohybrid cross. You can see here monohybrid cross. The parents capital T and small t has been taken. Capital T, this is for tall, this is for dwarfness. Okay. So if you initially do the cross, so you get all the plants as tall plants. Okay. All are the tall plants you will get. So that is your F1 generation. Then if you go for the selfing of this one, there will be help of the monohybrid cross. The Punnett square will help you there. So you do the selfing. So now you see capital T small t, because both are capital T small t here, you are doing the selfing. So your gametes will be your capital T and small t, because they will become haploid. Okay. So here also capital T small t. Okay, it will become haploid, both the parents. Okay, male and female. For example, this one you take as male and this one you take as female. Okay, so now what is the outcome of this? Outcome will be, now just you have to capital T and capital T, you got capital T small t. Here also get capital T small t. Now also capital T small t, then small t. So through the Punnett square you can very easily see that this will be tall plant, because both are homozygous. Capital T and small t, according to the laws we have already seen that this is your capital T, then capital T small t, you got the capital T, then small t. In homozygous condition, if it is a recessive, it will give you a dwarf plant. Okay, so now phenotype 3:1, 1 2 3. Phenotype means what is the morphology, how it looks like. It will be a tall plant around 2 meters, and the genotype will be your 1:2:1. So 1 will be homozygous tall, 2 are heterozygous tall. These are heterozygous tall, capital T small t, and this is your homozygous dwarf. Okay, so by the help of Punnett square we are doing. So similarly, now we'll go for a test cross. What is a test cross? Test cross is a method to identify the genotype of unknown plant. So this is your unknown plant. Okay, suppose this is your unknown tall plant which is unknown. So now it may be, the genotype may be capital T, may be capital T small t. Okay, so anything, anywhere it is, it will be around 2 meter tall, because the length is 2 meter and dwarf is 0.5 meters. Okay, so it is a tall plant. So now what you have to do in test cross, you have to cross it with a variety which is dwarf in nature, small t, which is dwarf in nature. Okay, so now if it is tall like this, homozygous tall, then the gametes will be your capital T of this plant, and the gamete of the dwarf plant will be small t, because this homozygous for both the alleles. Okay, so all the plants, if you do a cross TT, this one TT, this one TT, so all the plants you will be getting tall plant. Okay, in this case, if it is having the genotype capital T small t. Okay, so what are the types of gametes you get? You will get two types of gametes. One is capital T, another one is small t. Gamete formation we have already seen in previous videos, you can refer it. So now what is the genotype of the small plant? That is small t. So you will get only one type of gametes. Two gametes you will get, but one type, that is small t. So here if you see, if you do the Punnett square, you will get capital T, then capital T, small t, here small t and small t. So how many tall you will get? 50% tall and 50% dwarf. So here 50% tall and 50%, this is 50% tall and this is 50% dwarf plants. So from here you can confirm that what is the genotype of this plant. Once you do a cross and collect the seeds and cultivate the plant, you will get the clarity. Now quickly come to the your dihybrid cross with the help of Punnett square. So dihybrid cross, you can see here the parent generation we have taken the yellow and brown. Okay, green and wrinkle. Okay, we did the initially the cross pollination. Then what are the type of gametes we'll get here? Here the type of gametes you will get, they will be homozygous, okay, one Y and one R, because we have already discussed in previous videos that in case of Mendel, both the genes are present in separate chromosomes. Okay, so now here if you see small y and small r, so in the F1 generation all the types of plants you will be getting will be yellow and R, but they are heterozygous for both the genes. Okay, so now this one I have already done, but for your clarity I have done it again. So you see here capital Y, small y, capital R, small r, they are in separate chromosomes. Okay, so now once the meiosis will happen, okay, so these four types of gametes it will form. This is a parental variety, this is a parental variety, these two are non-parental varieties. Okay, capital Y small r and small y capital R, non-parental varieties. So now by the help of Punnett square, if you do it, see here, this is your male, this is the female. Okay, both are having same types of gametes you will get, all four types. Now if you do a Punnett square, okay, if you do a Punnett square, you will be getting 4 into 4, total 16 small squares will be there. And here in F2 generation, what you will be getting? You will be getting the phenotypic ratio yellow round 9, green round 3, yellow wrinkle 3, and green round will be 1. Okay, so actually that is the ratio, but actually when Mendel did it, he got 315 yellow round, 108 green round, then 101 yellow wrinkle and 32 green wrinkle. So overall ratio he got 9:3:3:1. Okay, thank you.